Hello, it's Dan Alford with ARC Specialties. We're out in the shop. I want to show off a machine that we've been building for almost 20 years now. This is a sand screen machine, but I'm going to let you hear from the expert. James, explain this one to us.
Hi, I'm James Lippold, Vice President of Design of ARC Specialties. Been working here for almost 21 years. My very first project when I came here was a machine to build sand screens. And what we started with was an off-the-shelf seamer that was very good at seaming sheet metal and whatnot, but it wasn't quite as precise as what we needed to make sand screen. Sand screen has a very high tolerance of the gap width. So it's very important to maintain that consistent gap in the screen while we're making it.
And so this is actually a resistance weld.
It is.
And so as we're wrapping the wire around this part onto the rib wires, we're having to make 100 welds per second, hold the accuracy of the position of the wire within a thousandths. And if you see any sparks at all, that means you made a bad part and they scrap it. No challenge at all.
No challenge.
So we're running, this is your head, right? This is your design?
Yes, it is. And this is a second version of this head. So we started with, it's a basic spindle block with bearings and whatnot. And so we added some precision ceramic bearings. Ceramic mainly just so we don't get any conductivity through the bearings. As you can see, there's lots of phenolic construction throughout, and that does a lot of the insulating. Because the goal here is to get the power straight to the weld head and then along the copper shaft and out to the welding portion of this weld wheel here.
What amperage are we conducting through this thing?
It's capable of going up to about 5,000 amps continuous. It's typically not that high in the practical world, but it's capable of doing it. So this is where the incoming power comes through, and so we'll have a water-cooled power cable that attaches to this lug here, and then you see this fabricated brush mount here that we made ourselves, and that's going to transfer the power to both sides of these brushes here. So these are the carbon brushes, and that transfers the power through these wires to this copper ring here. And then that transmits back down the shaft, back to our weld head, where all the welding occurs.
This is only at a few volts, but it's at relatively high frequency and up to 5,000 amps. James, we're looking at some coolant lines. Normally, welding and water don't go together. Explain what's going on here.
Well, after it's going through the weld process, the metal is very hot, and so the goal here is to quench that weld, cool down the metal as quickly as possible.
So you're actually welding underwater?
Essentially, yes.
And this is, the materials we're running here are stainless and Inconels?
Correct.
And so the quenching doesn't cause any problem and it simply improves our welding?
Correct. I believe it makes the weld more stable, so it helps take care of the gap control.
So Johnny's going to do some cutaways, but what we're doing is we're building one of these screens that's 40 foot long. So we start out with rib wires that are 40 feet in length. And you do both wrap on pipe and jackets, right?
And jacket, yeah. So this is an example of a jacket. So there's just no pipe inside. It's a product that they typically sleeve on pipe and then have end rings that hold it in place. So it's two different versions of sand screen.
So what we're doing is we're feeding this wire in, and the width of the wire can vary by what? What's good wire tolerance?
Good wire tolerance that's specified as plus or minus 7/10. And so we're trying to maintain a gap of, we strive for plus or minus 1 thou, but it's really based on how good the wire is.
And so the problem, if your wire is varying by 7/10 of a thousandths and we're trying to hold 1/1000th gap, it's hard to get there from here. And so we actually have a patent on this. This is one of our few patents that we're actually making money on, I think. But we measure the width of the wire as it feeds into this machine, and if the wire trends wider, we simply change the helix. Nobody cares what our pitch of the wrap is, they only care about our gap. So this is the weld head?
So this is the weld head spindle here, and what I'm holding here is the actual weld wheel. This is where the action takes place.
In that little step.
And there's a little step there, and that's a pretty standard industry practice, is to have a step, and it's usually the shape of the wrap wire. That way it holds that wire nice and tight in that step as it's welding.
So I remember when we first started doing this, we would machine these wheels on a lathe in our machine shop and then put them on the machine.
Right. And so,
you changed all that.
Exactly. And so when you're machining on a lathe, that run out of that wheel is only as good as what you did on the lathe. Once you apply it to the weld head, it's different center lines. So what we've done here, a combination of a couple things. This is a dressing tool, and it's just made to do light cuts to cut that step. It's also used to change wire sizes, but mainly just to dress it, because over time you may get some buildup on the copper wheel there.
So you built a lathe?
Exactly. A lathe on top of a lathe.
On top of a lathe. How many of these machines have you built now?
We're at least 20 plus.
And they're operating all over the world?
All over the world, yes.
Yeah. So I wanted to show you the guy that actually machines and builds these things. This is Chino. I met him in Lima, Peru many, many years ago. Now he works here at ARC Specialties. How many of these have you built over the years?
23,
And that's over the last, how many years have you worked here?
13 years.
So you machine the parts, you assemble the parts, and we're able to hold the tolerances.
Yes, sir.
Great job.
Thank you.
One thing we added also to go along with this dressing tool is we put a servo motor on here. Normally, back in the old days, 20 years ago, we just relied on pressure for a friction drive to rotate that wheel as the headstock was wrapping the wire. But now we have a servo motor, and we use this for two functions. One is to give it we use it in torque mode, and that allows the wheel to force it to follow consistently. So if you're varying in pressure or run out of the pipe, you don't get any slippage of the wheel, because slippage of the wheel usually means a bad weld. So we use it for that function as well as the dressing tool. So we can turn the servo motor on in speed mode, where we can control the speed of my second lathe while we're dressing the wheel.
And where was all this built?
In Texas.
Right here at ARC Specialties.
Absolutely.
Every piece you see was built here.
Yep.
And so it's, you know, what we've done is we've taken a process that's normally used to make trash cans and barrels, and we've turned it into a precision welding process that can produce parts accurate plus or minus 1/1000th of an inch.
Yep.
Pretty amazing.
It is amazing.
Done a great job on it, and the only problem I got is you guys never leave the design alone. You're continuously improving it.
I agree with that. We're actually looking here today at a new left-handed version. It looks the same as the right-handed version, but now we're building left-handed machines.
Because your customer asked to have two machines mirrored, so you have one operator.
One operator and conserve shop space.
And you agreed to this?
I did. It was a lot of extra work, but made our customer happy, and hopefully they'll have more room to buy more machines.
So they bought at least two?
Yes, they did.
It's been fun watching this machine evolve, and no, I agree. Continuous improvement, that's what we do here at ARC Specialties, and really created an amazing machine. Resistance welding isn't considered to be a precision process at all, but you've kind of changed the paradigm.
Yeah.
Keep up the good work.
Thank you.
At ARC Specialties, we thrive on problems. Send us yours.